Unit 9, page 5. We have a calculator for this one, so you make sure you get that out. What you're looking at here, we have the number of gallons, PFT, of a pollutant in a lake that changes at a rate. This is a rate given to us in gallons per days. P is measured in days. There are 50 gallons of the pollutant at time 0. So the pollutant at 0 is 50 gallons. So that's my starting point. The lake is considered safe when it contains 40 gallons or less of a pollutant. Okay. Is the amount of pollutant increasing at time 9? Why or why not? Go back to your justifications. The pollutant is increasing when its derivative is greater than 0. So I want to find P prime of 9. Get an answer so I can see, is it increasing or is it decreasing? So what you want to do is you want to get your calculator out, and we're going to type in this equation. 1 minus 3e raised to the negative 0.2 radical x. So I've got my equation typed in there. Make sure it's typed in there nicely. I'm just going to check my window, make sure everything's okay. I just have my standard x is time, so I'm going to go 0 to 10, see what that looks like. We'll graph that, see what we get. Okay, so now, again, I want to find P prime of 9. That's what I'm looking at. So that means that I want to know when x is 9 on this graph, what is the y value. So I'm just going to hit trace, and then I'm going to hit 9, enter, and I've got a value for P prime of 9, that's the graph of my calculator, negative 0.646. So because that is negative, the amount of pollutant is not increasing because P prime of 9 is less than 0. Okay, so it's very clear. They asked in terms of increasing. I mean, I could say that it's decreasing, but it is not increasing. That's what they asked. I answered how they asked it. Okay. Part B. For what value of time will the number of gallons of pollutant be at its minimum? Justify your answer. Well, a pollutant is a min when P prime is 0 or DNE and has a sign change from negative to positive. So this is where I'm going to go right back to my graph. Now, if you look at this, it looks like this graph is increasing. It's definitely getting closer to the x-axis. So I'm going to go to my window, and I'm going to send my x-axis out further. I want to know when P prime is 0 or DNE. I need to really explore this to see what's happening. So again, I just went out to 20, I think, definitely getting closer. So now I'm just going to send that out, I don't know, I'm going to throw a 50 in there just to kind of get this going, see what happens. So I'm watching this. It's getting closer to the x-axis, and it looks like I might be crossing it. Yeah, it looks like it crosses someplace in here. So I need to find when P prime, that's my graph, is 0. So I'm going to do second trace, option 2, left bound. Notice that my y-coordinate, if you can see this, I know it's really small, but if you look at this, my y-coordinate right here, that is a negative, okay? So I can say enter. Now my right bound, I know I'll be to the right. I want that y-coordinate to change to a positive. As soon as it changes to a positive, there we go. Now I know that the 0 is somewhere in between a negative and positive y value. So I've got a 0 right here, and because it went from negative to positive, below to above, so I know that is my answer. Let's see, so find T. So the T, the minimum is 30.174 days. Remember AP rounding rules, you're going to 3 decimal places, okay? Now here's the big part of this question right here. Is the lake safe when the number of gallons of pollutant is at its minimum, okay? So I need to know, we just found out when we're at a minimum. I need to know, well, what is the value of the pollutants at that time? So that's what I want to know down here. How many pollutants are in the lake at 30.174 days. So if you think about this, this is just a take on the same particle motion problems we've been looking at. This is a new position, if you will. I want to know the pollutants here. Well, that's going to come from how many pollutants were there at the beginning, plus I'm going to add up the pollutants that were entered into those lakes. See what's going on. Are they coming in? Are they going out? What's happening? Is there a rainstorm that cleans out the lake? We don't know. So I want to know the displacement, if you will. How has that pollutants changed from 0 to 30.174 of P prime of T dt? If I integrate the rate, I get the pollutants. So I want to do this. Now the starting is 50, and now I have P prime on my calculator. Second trace, I'm going to go to option 7. It's going to ask for a lower limit of 0, enter. My upper limit is 30.174, enter, and it's going to give me that answer. Hopefully. It's going to go a little slowly, but we'll get there. Now, this area is below the x-axis. That's negative, so this is a good thing. And I've got an integral of negative 14.89564, it looks like. Don't round those answers until the very end. So now the pollutants at 30.174, if I just subtract these, I've got 35.104, and the pollutants are measured in gallons. Now, make sure you answer the question. Is the lake safe? Yes, it's safe because 35.104 is less than 40. 40 is that safe number. You want to make sure you get that comparison in there, okay? Now, part D. An investigator used the tangent line approximation. Tangent line approximation means we need a tangent line equation at 2p at t equals 0 as a model for the amount of pollutant in the lake. At what time, we're trying to find t, does the model predict the lake becomes safe? Well, remember, we are safe when the pollutants is 40 or less. That's our safe point, okay? Tangent line approximation, y minus f of x equals f prime of x times x minus x1. So now, let's adapt this equation to our variables in our problem. I'm not using a y here, I'm using p. We've got pollutants in this problem. Minus p of 0. They want us to look at time 0 equals p prime of 0 times x minus 0. That is the x coordinate. That's the time that we're focusing on. Starting is 50. P prime of 0. I've still got this on my calculator. Trace, 0, enter. P prime is negative 2. And then this just is x. Now, we want the lake to be safe, so I need the pollutants to be 40 or less. I'm going to sub this value in for P. So this becomes 40 minus 50 equals negative 2x. I really should have converted my x variable to a t, but we'll get there. Negative 10 is negative 2x, so therefore 5 is x. At what time does the model predict the lake becomes safe? The lake is safe after 5 days. There you go. Hopefully you're starting to see how so many different aspects of what we've done this year are incorporated into just one problem here. But hopefully it's starting to make some sense.